Assalamu alaikum warahmatullahi wabarakatuh. Hello everybody. Today I'm going to explain sigma notation. That's sigma notation. Before explaining sigma notation, you have to understand the sequence and the series. So this simple means find the sum of the series. Find the sum of the series. So the next question is going to be where is the series? Okay, so now I'm going to erase everything and I'm going to show you how to find the series. So if you look over there, when we have the sigma notation, you're going to have here a variable and it's equal. Here we're going to have a number and here we're going to have a number. And next to the sigma notation, we're going to have a formula. So how it's working? Again, I'm going to explain in more details. I'm going to erase again. So here, for example, sigma notation, x equal to 1, and on the top you're going to have, for example, 5, and here I'm going to have, for example, 3 plus 2x. So what does it mean? I have to start plugging with the bottom value, so x equal to 1, after that equal to 2, after that equal to 3, after that equal to 4, and I end by 5. 5 as we see the number all the way in the top. So when I plug in that formula, I'm going to have 5 terms. So let's plug in. So when x is 1, 1 times 2 is 2, plus 3 is 5. That's the first term. Now when x is 2, 2 times 2 is 4, plus 3 is 7. When x is 3, 3 times 2 is 6, plus 3 is 9. When x is 4, 4 times 2 is 8, 8 plus 3 is 11. And when x is 5, 5 times 2 is 10, plus 3 is 13. So now I got the sequence. So now this is a sequence. I have the terms 5, 7, 9, 11, 13. Now the sigma notation means I have to add all of them. So what does it mean? 5 plus 7 plus 9 plus 11 plus 13. When I add all these terms, it's going to come up by, that's 45. Okay. What we observed here, okay, I'm going to show you more stuff, more tricks. Like for example, now I see the sigma notation. Oh, sorry. Here is the sigma notation. So as I said, here is a variable. Here is the top. Okay, what's next to here? The formula. If the formula is a linear equation, so I have arithmetic sequence. But what if there I have an exponential equation? Like for example, I say So 3 times 2 to power x. That's exponential one. So I'm going to have a geometric sequence. And as we know, the difference between the arithmetic sequence and the geometric sequence, in the geometric sequence, I added a certain difference. Like, for example, I add by 2, I add by 3, or I subtract by 2, I subtract by 3, or subtract by 5. But in geometric sequence, I multiply by common ratio. This common ratio may be an integer, which is going to be, for example, 2, 3, 4, 5, or maybe a fraction like maybe 1/5, 1/4, and so on. So we understand now that sigma notation is asking you for a series. Okay, now we have, do I have to find all the terms? Like, for example, imagine if I have in that sequence 20 terms. Like, let's say I have sigma notation x equal to 1 till 21, and I give you 2x plus 3. Okay, again. So now, how many terms do I have in the sequence? I have 21 terms. How I got that? 21, that's the number on the top, minus 1, the number on the bottom, plus 1. If you don't understand it, so we can count from 1 to 21. So I have 1, 2, 3, 4, 5. Here is 5, 6, 7, 8, 9, 10. Here is 10. And if you continue counting, you're going to find them that they are 21 terms. Okay, so can I use a shortcut for that? Yes, I can use a shortcut. Since I know that it's arithmetic, why? Because this is linear. So I can use the series for the arithmetic series. How? We know that the sum is n equal to the number of the terms divided by 2, the first term plus the last term. That's the formula. So if I got, now I found n is 21. So what I have to do to find a1 and a21. a1, when x is 1, so a1 is 5. a21, when x is 21, which is going to be 45. Now I can plug in the formula. So the n is going to be 21. The first term is 5. The last term is going to be 45. I can now finalize my calculations. So it's 21 divided by 2 multiplying by 50, which is going to be 1050 divided by 2, which is going to be 525. So if I added all the terms in the sigma notation, it's going to be 525. Okay, so now this is for sigma notation for arithmetic sequence. I'm going to upload another video for sigma notation for infinite series and sigma notation for geometric series. Thank you. Good luck.